Hello, everyone, and welcome to today's ASRG World Webinar. ASRG stands for the Automotive Security Research Group. Today is the 17th of June, 2021. We're streaming from Stuttgart. Thank you to Pascal Gross for setting up this streaming. Stuttgart in Germany, and I'm joining from Detroit, Michigan here in the US. Thank you guys for joining us. My name is Brandon Barry. I'm the Americas lead for the ASRG. The ASRG is now 4 years old. It's a nonprofit organization which provides a platform for the automotive security industry, as well as related academics or organizations to share knowledge, build networks, and create valuable collaborations. This community is for you, and it's based on volunteer support. If you want to know more details about the ASRG, you can always check us out at www.asrg.io. Send your questions over to hello@asrg.io or check out the links in the description of this video. Make sure you stay tuned into what we have going on here at the ASRG. We got some really exciting webinars coming up here in the near future. If you have an idea you want to get to us, you want to start your own location, you have an idea of a service ASRG can provide, you want to present on this stage, would love to hear what you have to say. Again, reach out to us at hello@asrg.io. So that's it from me. I'm sure you've been waiting curiously for our main presentation. Like every webinar, world webinar, if you have any questions during this presentation, make sure you throw it in the chat. I'll be gathering them up, and I'll be challenging and questioning our presenter at the very end of this. And now it's my pleasure to welcome Derrick Thiecke, vehicle reverse engineer at CANbusHack, right here in the Detroit area. Today, they'll be talking about powersports and recreational vehicle networks, kind of one of these areas around automotive cybersecurity that maybe gets less attention, but still share some of the risks that we deal with every day. So that's it for me. I would like to hand it over to Derrick. Derrick, the stage is yours.
All right, thank you, Brandon, and thanks everybody that is able to attend today. As Brandon had mentioned, I'm here to talk to you about power sports and recreational vehicle networks. A little bit about myself. I'm Derrick Thiecke. I'm a vehicle network systems reverse engineer at CANbusHack in the Metro Detroit area. You can find me on Twitter at CANbusDutch. And if there's any questions you think of that you didn't get a chance to ask at the end of today's webinar, you can feel free to email me at canbusdutch@gmail.com. I got involved in vehicle network reverse engineering when the manufacturer that made my beloved bike there, which is the only American-made production sport bike, an EBR 1190 RX, started having some vehicle network communication errors, and the manufacturer was experiencing some financial hardship. So parts availability was slim to none. Since I've taken on the project of resolving the issue, I've spoke at a few hacker cons, volunteered to put together a motorcycle and power sports chapter for the Car Hackers Handbook Rev 2. And now I'm actually doing some contract work with Eric Buell Racing, now known once again as Buell Motorcycles, to help further develop their vehicle network systems. So that is the synopsis about me. Let's get going here. What exactly do I mean when I say power sports and recreational vehicles? So when I say power sports and recreational vehicles, I'm referring to any motor vehicle that isn't part of the Euroregulation L that is part of the Euroregulation L category and that is not defined as a motor vehicle by ISO 3833. ISO 3833 is the broad scope term used by a number of government boards when instituting new standards. So anything that doesn't fall under ISO 3833 is not required to follow many of the standards we see in vehicles regularly. So what is the ISO 3833 defined motor vehicle? ISO 3833 defines any motor vehicle as any power-driven road vehicle which has 4 or more wheels, which is not rail-borne, and which is normally used for carrying people, towing vehicles used for the carriage or persons and or goods. And you'll also see down here that it does encompass 3-wheeled vehicles whose weight exceeds 400 kilograms, but that still doesn't cover motorcycles. And what is a Euroregulation L category vehicle? You can see there powered cycles, 2-wheeled mopeds, 3-wheel mopeds, 2-wheel motorcycles with or without a sidecar, tricycle, heavy on-road quad, and the list kind of goes on. You know, anything that isn't your traditional passenger vehicle. So, a history of controller networks on motorcycles. This here is the Ducati 999. It is the first motorcycle to be equipped with CAN bus, which was in 2003, which was over a decade after the first car in 1991. It had a very simple controller network. It consisted of just the ECU, the immobilizer, and the dash. So simple that many individuals didn't even consider it to be a fully integrated CAN system. And that's when we have the 2005 BMW R1200 GS, which many consider the first fully integrated CAN system, which had an anti-theft device, a dash, an ECU, ABS controller, and a chassis and controls management device. You'll notice as I go through the history and innovations that BMW and Ducati are kind of front runners in when it comes to tech innovation for motorcycles. So the growth of controller networks on motorcycles. In 2006, we saw the very first ride-by-wire motorcycle, which was the 2006 YZF R6. In 2011, BMW began integrating LIN bus on their 2011 line of motorcycles. And then here's another innovation competition between BMW and Ducati. So in 2013, Ducati introduced their multistrada with what they call the Ducati Skyhook suspension, and BMW introduced their HP4 race bike with dynamic dampening control. These were the first production bikes with semi-active suspension. And then in 2014, we saw motorcycle stability control, a variant of standard ABS where the bike's lean angle plays a variable in the system, introduced by Bosch. 2 years after that, the Euro 4 regulation or requirements began requiring all motorcycles over 125 cc to have ABS. And then in 2021, SAE announces new models from Ducati, BMW, and KTM will feature Bosch's new adaptive cruise control setup. I'm not very big on the idea of cruise control on my motorcycle, But for those touring guys, they love things like that. So all these controllers and no standards over the years, ISO, SAE, and government transportation boards have kind of failed to standardize many things on motorcycles to the extent that you would otherwise find standardized across manufacturers on cars. Let's take, for example, the DLC on motorcycles. So here we have 6 different DLCs. This photo alone, we have 2 Kawasaki, 2 Honda, and 2 Suzuki DLCs. And I wanted to note this this DLC here up in the top right-hand side, this MS460 Honda 4-pin cable, noted most popular. We're going to actually reference that a few slides later. So here we have 6 more. I threw this one in here because I wanted to show that one in the bottom center there, which is the Piaggio, Triumph, and Victory DLC, which is the standard vehicle J1962 DLC. So they kind of make things a little bit easier. And then here, this is why I noted the Honda unit, because if you notice down there in the bottom right-hand corner, we have an MV Agusta CAN 4-pin cable. This is the exact same DLC that the Honda used, but it says, warning, do not use on Honda systems because they have a different pinout and you can fry your ECU if you use the MV Agusta connector. So I'm not going to keep going on this. These were pulled from a Universal Diagnostics utility for motorcycle, the documentation of it. All in all, there was 35 different connectors across 25 manufacturers. So if you could imagine, if you're reversing bikes and doing some type of security test on it, it could be kind of a headache with the number of DLCs that you'll be introduced to. So typically, when I'm working with motorcycles, I tend to try to avoid anything that terminates directly to the J1962 DLC. I tend to use these devices that have the screw terminal blocks or the RS232. I've just found it a lot easier. But if you have a tool you really like to use and it's terminated directly to the J1962, you could always make an adapter or purchase one. They're readily available for purchase, on sites like Amazon and everything like that. I have one for my KTM, and it's been helpful to utilize some of the other tools. But oops. So if you do a little research and you dive deep into motorcycle DLCs, you might notice that in 2016, ISO published the 19689 standard, which is a standard 6-pin DLC. JST here actually created a connector that follows all of the IS2 19689 standards. So the only thing is despite this standard being created in 2016, I have never seen this connector on any power sports or recreational vehicle. For example, this is a DLC breakdown of some of the more popular bikes. You see over there along the left, the 6-pin standard created by ISO. And we have the Harley-Davidson 6-pin, the Harley-Davidson 4-pin, the KTM 6-pin, the Ducati 4-pin, and the Moto Guzzi 4-pin, none of which follow the standard. There was also a BMW 10-pin, even though they really only utilize 4 of the pins. I guess they're just kind of forward thinkers and wanted the opportunity to throw more stuff on there. But so now we have the DLC. What about the actual onboard diagnostic systems found on motorcycles? So nearly all manufacturers began implementing manufacturer-specific onboard diagnostic systems on new and popular models in 2003. You'll find, like the Ducati 999 we spoke about earlier, the BMW line of bikes, and even the Harley-Davidson Dyna, all began implementing manufacturer-specific onboard diagnostics. By 2010, nearly all bikes had a manufacturer-specific onboard diagnostic system. And then over the past decade or so, we have seen some of the larger manufacturers, primarily those also invested in vehicle manufacturing, such as BMW and Honda, adopt vehicle CAN application layer standards, such as ISO 14229, which is UDS, and the SAE J1979 OBD2 PID standards. But finding these on any vehicle that doesn't meet the ISO definition of a motor vehicle is still a very hit or miss situation, as the OBD2 PID standard is kind of for the regular emissions testing, so that shops can easily test the emission system. And since motorcycles typically don't require those annual testing or regular testing, they just don't care to put them on there. So, but there is hope. All of this will soon hopefully change. We have Euro regulations. Euro 4 and 5 will now require all 2- and 3-wheeled vehicles and quadricycles to be equipped with a standard DLC. The legalese in the documentation states that in 2021, introduction of a second stage onboard diagnostic system allowing advanced identification and flagging of malfunction and deterioration of emission control systems. The connection interface between the vehicle and the diagnostics tester shall be standardized and meet all the requirements of ISO 19689. I've spoken to quite a few people about this Euro 5 requirement, and often they believe, OBD2, like bikes are going to have SAE J1962 DLCs on them. But as you can see here, that's not the case. They're going to use that red JTS 6-pin connector that we had spoke about earlier, which I'm kind of relieved, because the J1962 is kind of a big connector, and I don't think it has a place on small bikes. And thankfully, it does not stop at the DLC. Euro 4 and Euro 5 will also require all 2- or 3-wheeled vehicles and quadricycles to meet multiple standards as they apply to PIDs and OBD2 IDs. So the legalese, when a fault is registered, the manufacturer shall identify the fault using an appropriate fault code consistent with those in ISO 15031-6, and the vehicle manufacturer shall provide to a national standardization body the details of any emissions related diagnostics data, such as PIDs, OBD monitor IDs, test IDs that are not specific in ISO 15031-5 or ISO 14229, but relating to this regulation. I can't wait. So we're finally going to see some of the OBD2 standards on the application layer on recreational and power sport vehicles. So it was long overdue. We're almost there. Nearly 25 years after cars instituted the OBD2 umbrella standard, we're finally coming to terms with the idea that road legal power sports and recreational vehicles should have a unified diagnostics system. This is pretty crazy, considering that a lot of people think of motorcycles as innovative, especially those like Honda and stuff like that, to be 25 years behind vehicles when it comes to these standardizations. But what about the last 25 years of bikes and CAN bus reversing? Typically, the reversing process involves utilizing an application layer standard to make diagnostics requests and compare with normal messages, either visually or with software. But we don't have that option here because all motorcycle diagnostics are manufacturer specific and top secret over the past 25 years. So let's look into how we might do that. Reverse engineering a motor vehicle not defined by ISO 3833 as a motor vehicle pre-Euro 5. So let's get started. You've taken a look at your bike's DLC, determined the connector and the pinout, and put together a means to connect your CAN reverse engineering tool to your bike. After you're up and capturing data, you went through, thoroughly tested for common application layer protocols like OBD2 PIDs and UDS, and most likely got no response. So we've done our recon work, we're capturing data, and we're ready to go. One huge advantage to motorcycles and other recreational vehicles is that much of what we need to work with is generally accessible without much disassembly. With easy direct access to many sensors, you have the ability to directly manipulate this data. With a potentiometer, a 2-position latching switch, and a signal generator, you can simulate nearly any engine sensor data. So you basically will back probe into some of these connectors. Some of them you'll need to disconnect the connectors and create an adapter to plug in a potentiometer, like temperature and the thermo resistors. You just plug in the potentiometer to it and give it a little twist, and you could manipulate the engine temperature. Then, sometimes it's not really the best idea to start manipulating engine sensors while, your ECU is plugged into your bike. You can cause potential harm to the engine, and, who knows what will happen. So there's also bench testing. I found bench testing to be a very viable option for motorcycle reversing. It's actually, one of my favorite means of reversing the bike. The wiring harness is compact, the modules are small, and typically terminating everything down to a terminal block is very simple. Here's an example. Sorry about my little rat's nest of a wire going down to the terminal block there. But this bike here is a very simple network. It's consisting only of the main ECU, the dash, and I've terminated pretty much everything down to the terminal block, except for 2 DLCs. This bike had 2 DLCs, one which was a J1850, and the second one which just carries the can. And yeah, I later connected a dash and a microcontroller, which I control via a command line interface, to the opposite terminal block. And I was able to simulate nearly the entire bike at my desk to reverse engineer the bike, which it's kind of good, on those hot summer days in California. I wasn't in my garage huffing exhaust fumes the entire day. So let's take a little look. This is a video of me sending different commands and simulating the sensor data. So let me make this full screen here. So oil pressure true. You'll see the low oil light up top go off there. Next, I'm going to change the neutral switch, and you'll see the green in there goes away.
Hey, Derek, not to interrupt, but can't see the video.
You can't? Okay, I apologize. Can you see it when it's smaller like this?
Nope, I think perhaps you're only sharing the presentation. Oh.
Oops. There we go. I apologize. There we go.
Okay.
All right, so here we go. Sorry about that, folks. Oil pressure true. You'll see the low oil light turn off up there. And then next, we'll go into the neutral switch, equals false, and you see the neutral disappear. Next, we'll go into the low fuel. And then the low fuel must remain true for 20 seconds before the ECM flips to the low fuel bit to true. And so just, when you're leaning around, it won't flop back and forth on and off. So any second here, you'll see the low fuel light turn on and the odometer switch to the fuel trip. And then now we're going to simulate some RPM frequencies at 1001. That's not really the actual RPM speed. That's just the speed that I fed the signal generator at. And now we got our speed going there. And you can see my fuel trip mileage went up a little bit there because it thinks I was going 55 miles an hour. So yeah, so there was the engine simulation. It was, oops, sorry about that. A pretty easy process. It does take a little bit sometimes of mechanical reverse engineering. Like my RPM uses a crankshaft, a Hall sensor that sits around the outside of a tone ring. I had to know how many steps that tone ring had in it, which it had 36, and then it had a timing gap, the equivalent to 2 steps. So I had to work to simulate that with the signal generator that I had. So in conclusion, pre-Euro 5 bikes require a bit more hands-on approach, but engine simulation is fun. I like it a lot. It requires a bit more creative thought and innovation. Euro 5 bikes meeting all onboard diagnostic standards have started to hit the sales floor. I think I might have to go out and purchase another bike in 2022 just to test this and to have some fun with it. And, if you're looking for a new hobby, go get yourself a Euro 5 compliant bike and start hacking and get your motorcycle license. I would love to see more folks out there hacking motorcycles and other recreational vehicles, UTVs, Spider Can-Ams. Get out there and do it. It's a field filled with innovation, and surprisingly, it's when it comes to technology and the vehicle networks, it's just not really as popular as one would hope or think. And so here, I want to say thanks to everyone. Thanks to everyone down at Buell Motorcycles in Grand Rapids, Michigan. I want to say thanks to my buddy Jens at NCCR in Sweden. He helps me a lot with researching the Euro 4 and Euro 5 and understanding all of those new Euro regulations. And basically, that is it. So I guess this is where we'll open up to questions.
So Derrick, thanks a bunch for this this presentation. It's really cool. A motorcycle rider myself, or former motorcycle rider. It's really cool to see kind of the history here. It's not something I've taken a look at, but it's always I spend most of my time in vehicle security. By that I mean passenger vehicle security. And you're right there. It's more standard driven. You kind of bigger systems, more ECUs, more networks, more standardization needed. But when you get into these fringe branches of different types of vehicles, so here we're talking about recreational vehicles and power sports vehicles. There's other areas like tractors and mobile off-highway systems. You just start to get into these kind of derivatives of technologies in vehicles that are likely going to be connected and feature rich, that share some risk that we think about with automotive security, but maybe aren't paid the same attention to or don't have the same history behind it. So I thought that was really cool to see that kind of unfold here with motorcycles. I wanted to ask you, being a rider yourself, maybe having some insight into where motorcycles are going. Do you have a sense of what kind of connectivity motorcycles will have or do have, or anything like that?
Yeah. You mean like in the sense of like when it comes down to self-driving and stuff like that?
Yeah, well, I wouldn't expect a self-riding motorcycle. That sounds terrifying. But no, I mean features. I don't know. I just know that, cars are being reinvented right now because of your ability to, have a computer in the cloud, pushing some features to it. I'm just wondering if there's anything like that on the roadmap for motorcycles too.
Yeah. So there is like what I had mentioned earlier. Probably the next big thing is adaptive cruise control, and just as you had mentioned as well, that adaptive cruise control on a motorcycle just seems very frightening to me. But there are individuals who tour across country on bikes, and I'm sure they would love that feature. So that's probably the next huge feature. But one thing that's really interesting is there is cloud services when it comes to data capture and stuff like that. A lot more in the actual power sports industry. So, for track data and stuff like that, the amount of information that is now gathered, from a rider and from the actual vehicle, and now just like wirelessly uploaded to the cloud instead of on a device. Because if you think to the power sports industry involves crashing, and if you have a device on the bike, there is a chance that when you go down, it can get destroyed and you don't really know what happened. So you'll find that track data for factory teams and even privateered teams is now often uploaded to the cloud in real time to later look back and realize what suspension setups work better for riders, how much maybe a rider's weight is impacting being on such a small vehicle. A rider's weight plays a huge role. So yeah, that's pretty much where things are going right now in the realm of power sports.
Yeah, well, and it'll, I think it will change once you get standardized diagnostics on board. In the automotive space, you saw what, insurance companies quickly latch onto that to say, oh, we can read vehicle speed, we can read, a location of the vehicle, and we can come up with some predictive model on how likely this particular driver is to get into an accident. Probably the same thing will evolve with motorcycles or other features. Like if I'm going long distances on my motorcycle, having the ability to track where I've been may be a feature that people look forward to. Point being that I would imagine that these motorcycles will have some connectivity. There's just so many features that come with that connectivity. It's hard to avoid it.
Yeah.
So Derrick, getting into the details a little here, you had talked a little bit about the diagnostic connector. In cars, they standardize the connector for largely emissions purposes, which led to kind of a single spot to look on most cars. It's right under that dash, or right by your feet, usually in the vehicle when you're driving it. For those people listening, where should they look on a motorcycle for that diagnostic connector?
Yeah. So it does vary, and sadly, the ISO spec that is being introduced with Euro 4 just states that it has to be easily accessible to the owner. That it but on pre-Euro 4, Euro 5 vehicles, you know, it's kind of hit or miss on where it's at, and the complexity of getting to it. As you'd expect, just with vehicles, of course, they can't do it with the DLC because of the required standard. But you get certain manufacturers that just kind of make things hard to do, and then other manufacturers that are like, here you go, it's right here. So on some bikes, you'll easily find it, maybe right around the dash unit. You'll find that with, bikes like Gold Wings and, that have a lot of fairings and stuff on that it'll be kind of up in the dash area. And then some other bikes, you'll find them in the tail section, where there's typically a little bit of cargo area. But then there are other ones that would require you to remove the entire like tank section, and to get to them and stuff like that. So it still varies a little bit. Hopefully, with the Euro 4, Euro 5 saying it has to be easily accessible to maintenance the vehicle, it'll be a little bit easier to find and not be hidden away, and require some, not require disassembly to get to it any longer.
Gotcha. Yeah, and you would hope that you take your bike to a dealership, that those dealership technicians can kind of quickly plug into it without having to disassemble anything, because that's another value of these. Well, really the only, or I guess the intention of them, is that they, the dealers can quickly diagnose what's going on with that that vehicle, or motorcycle, I should say. So CAN bus, in the car world, one of the biggest groups hacking cars are those trying to tune them. Motorcycles have shifted from carbureted to fuel injected, kind of following that a couple of decades of being behind the automotive industry. And, I saw it kind of happening in the early to mid 2000s with Harleys. Um, so, usually those are driven by an electronic control module. Um, can you describe the motorcycle hacking for tuning purposes? And is that becoming kind of a growing field, or is that still, you're better off just putting in a standalone ECU or something?
Yeah. Well, in uh, in the motorcycle community for my bike, for the Buell, it's a huge thing. About a decade or so ago, somebody had created a third-party software that allowed you to hone in and flash your ECU and stuff like that. Um, you know, One thing that I hope that with the Euro 4, Euro 5 standardization is that it'll become a little bit easier to flash these ECUs, because right now, with everything being manufacturer specific, it takes quite a bit of reversing to get in there and really figure out how to flash them. And then some bikes too, they'll have like how I had mentioned the bike where I did the bench testing to it. It had two connectors, DLCs. It had the CAN bus DLC, and then it had the J1850 DLC. And the J1850 DLC was used for flashing the ECU, and the CAN bus one was used to do basic diagnostics and stuff like that. So you kind of end up with crazy things like that every once in a while, where you can spend all this time reversing the CAN bus, and then later be like, wait, what's this connector hanging out over here? What the heck? There's a whole nother uh, thing going on here. But yeah, I do hope there's a sorry, yeah, go back there. There's a utility called is it? Yeah. Come on, shoot. There we go. Sorry. There's a utility called Tuner Pro, that it's it's taken on a lot of popularity in the motorcycle community. It is very popular amongst cars too, but it's one of the very few pieces of software that are that have been adopted by the motorcycle community. You'll find it's a closed source piece of software, but you can develop like plugins for it and stuff, and it supports tons of the Japanese and European brands and everything like that. So if you're looking to tune your bike, I would recommend checking out Tuner Pro. It's an awesome piece of software, and it supports a ton of bikes.
Well, and I would, if this industry follows most other vehicle industries, manufacturers don't want people tuning their bikes. So, as we get into a more maybe easy to access standardized bus protocol, I would imagine that the battle will start with things like encrypted ECUs, and so on. I really can't imagine the manufacturer seeking to make it easier to hack motorcycles. But that's something that the manufacturer will have to contend with as they standardize these communication networks and implement them, because they're really still even in that process. So we got a question from the audience about electric motorcycles. So I've seen a couple of them out on the market. I'm sure they will come out just in full force following electric vehicles once people start getting chargers installed in their houses or whatever. So an electric things tend to be a lot more connected. Maybe they have more controllers on board. Can you talk about the difference in architecture between an electric motorcycle and a, kind of these traditional motorcycles?
Yeah. I mean, of course, with an electric motorcycle, with a combustion engine motorcycle, the primary controller is the engine management, the fuel injection controller. So, of course, that goes out the window, but there is the power delivery module, or, whatever you want to call it, or the manufacturer calls it for their given bike. Yeah, I don't know. I've dealt a little bit with a few different electric motorcycles, and my primary complaint about them is that they are really, really heavy. They, like the ones I set on, weighed closer to 500 pounds, which might not be terrible for those those who typically ride touring bikes and cruisers and stuff like that. But when you come from a sport bike that weighs about 400 pounds, that's, an extra 100 pounds is kind of a big leap. And then, I mean, another huge thing is that electric bikes aren't going to fall under a lot of these categories that, or, some of them won't, under the Euro 4 and Euro 5 regulations. So we'll probably see a whole nother line of electric motorcycles released that, are super limited on their standards again. So yeah, there's a few brands. Some of them have already came and went. My favorites that already came and went was the Victory Impulse TT and RR. Sadly, Polaris decided to do away with Victory to focus more on Indian. And then there is the Italian brand Energetica, which is an amazing electric motorcycle. And then, of course, one of the front runners out in California, Zero. And Zero's put together a ton of stuff. I got a chance to check out, quite a few Zeros, and they're amazing. But yeah, I think it's still going to be an uphill battle when it comes to standardizations for those. And, with the fuel injection controller disappearing from them and being a very basic vehicle, it's not like Tesla, where Tesla was able to implement all this other crazy self-driving features. So the controller network is just huge on an electric vehicle like a Tesla. It's probably going to be a pretty basic setup.
Well, and you wonder with those kind of electric vehicles tend to be more innovative. Would technologies like V2X or V2V work their way into motorcycles for maybe collision avoidance or other features? That's where I start to think, where we'd probably see our first adoption of those kind of things.
Yeah.
Cool. let me just check here. So, okay. So Derrick, I don't think I have any other questions for you. I don't see anything from the audience. Is there anything that you want to leave this audience with before we take off here?
Not really. I mean, probably just like my my prior slide there. You know, if you're looking for a new hobby, go get yourself a Euro 5 compliant bike. Start hacking and get your motorcycle license. Maybe not exactly in that order. Maybe you should get your motorcycle license first. But yeah, you know, it's an industry I'd like to see grow, and you know, I hope to meet more motorcycle hackers. I will throw out there that this year at DEF CON, I am attempting to bring a motorcycle to the car hacking village. So if you got some time and you're interested, it's a hybrid event this year. You can log in and remotely hack the motorcycle that I'm going to have there, or you could show up to DEF CON in person and have a look at the motorcycle and do a little hands-on hacking there. But yeah.
Awesome. Thanks, Derrick, for this presentation and really shedding some light on, you know, what it's like to hack motorcycles. You know, I will call this a niche of automotive security. But like many of these niches, I described it as branches or very, you know, focused areas within vehicles. Again, it'll share a lot of the same risk. It'll be us within this community that bring awareness to these types of things because, you know, at the end of the day, I think that a connected motorcycle will face a lot of the same risks a connected vehicle faces, whether it's ransomware or, you know, being remotely controlled. And you know, it's our job to keep those things or those vehicles safe and secure. So,
Yeah.
Derrick, thanks a bunch. I really appreciate your presentation and the light you shed on the subject. And we'd love to have you back and you know, keep at it. Keep at hacking motorcycles. I'd love to see it.
Yeah, thanks. Another thing I want to throw out there that I probably should have mentioned at the beginning of the talk is, yeah, you know, as I'm sure, you know, if anybody here rides motorcycles, you already heard it a million times, but riding motorcycles is a very dangerous hobby. So if you do decide to hack your motorcycle, you know, be really safe, you know, some improperly sent or not sent CAN messages can result in unexpected acceleration or deceleration, and you aren't protected by a huge metal cage like you are in a car if something like that was going to happen. So definitely be safe, and that's kind of one of the reasons. We'll take it back to the bench testing unit, why I really enjoy utilizing the bench testing unit, because I have an ECU that, you know, doesn't go in my bike. It's just there for bench testing, and I don't have to worry about the safety issue. So if you're gonna break into your bike and you're gonna hack it, just please be safe and you know, make sure you fully test it before you go back to town and go out for your ride. But yeah.
Great. Derrick, thanks again. And to the audience, thank you guys for joining. Stay tuned for our upcoming webinars. Really exciting stuff. Tons of webinars and people just like Derrick getting on this stage to you know, discuss their experience. All right, with that said, we'll go ahead and close this out. Thanks one more time to Pascal Gross for hosting this technically. I know the challenges that go along with that, so I really appreciate that. Okay, until next time, take care, everyone.